doesn't matter. Leave it like that. So you take 2 squared plus b squared equals, and then it's 2 square root of 5. But this is very important. You want to square the whole thing. So I actually should have put that 2 in parentheses. Whenever you're squaring something, it's probably a good idea to put it in parentheses like that. Okay. So now we're gonna simplify each of these parts here. I'm trying to get a little more room here. Let me scroll down just a moment here. Let's go. All right, so 2 squared is 4. Okay, now when you square 2 square root of 5, you're actually squaring the 2 squared, and then the square root of 5 gets squared. A square undoes a square root, so it becomes 4 times 5, or 20. Any questions on that, or anything you'd like me to clarify? You have to square both the number out in front, and then you undo the square root there.
Yeah, I get it.
Okay, and now we're just solving for b. Solve for b. So we subtract 4 from both sides. B squared equals 16. And then to undo a square, you take a square root of both sides. So squares undo square roots undo squares. And you only care about the positives. You don't have to do the plus or minus thing that you might have seen in another class.
Mm-hmm.
So b equals 4. And I hope you've seen this in class. Is it okay if I submit the answers as we go, or would you like to wait until the end to do that?
Submit the answers.
Okay. Maybe we can't go to the next one unless we submit them anyway. All right. Okay, so new problem. Again, really weird that they're angled, but whatever. That's nothing we can do about that. Okay, it says find the length of the third side. We don't know whether the third side is A, B, or C, so we have to go figure that out for ourselves. The legs are always made with the 90-degree angle.
Okay.
Okay, so in this problem, I'll make 8A and B the one down here, and this is C. The hypotenuse is always C, and it's always a good idea to start by writing the Pythagorean theorem. A squared plus B squared equals C squared. So we're gonna square the 8. We don't know B, we'll leave it as is. And then it's 4 square root 5, all in parentheses, squared.
Okay.
What is 8 squared?
64, was it?
Good,
No.
good, 64, Yep. Okay, now the one on the right, you have to square the 2 components. You have to square the 4 first. So it's really 16. And then the square root of 5, when you square that, it undoes the square root, so it just becomes 5. And 16 times 5. Do you, if you're allowed to use your calculator, please feel free. You can think of 16 as 5 times 10, 50. 5 times 6 is 30. 50 plus 30 is 80.
Mm-hmm.
Subtract 64 from both sides. B squared equals 16. Can you tell me the value of B when you take the square root of both sides?
Value.
Yeah, you're taking the square root of 16 to get down to your final answer.
4.
4. Good. So it happened to be 4 again. It's odd. Okay. Any questions on anything so far? We're gonna do more problems, but happy to answer anything on this.
No questions.
So notice in 2 problems, they've given you a hypotenuse and a leg, and a hypotenuse and a leg. Okay, they have to give you 2 of the 3 sides. They have to. There's no way to do it otherwise. Okay, find the length of the third side. Okay, so now they're giving you the 2 legs. They're giving you A and B, or B and A, depending on how you want to see it. And you need to find the third. Okay, so you're going to write, again, the Pythagorean theorem. A squared plus B squared equals C squared. So we have 9 squared plus 7 squared equals c squared. I am violating my convention here of putting the numbers in parentheses. If they're, you can do that. I really should. So I might as well just do that. Be a good student here. What is 9 squared? Can you tell me that?
81.
81. And 7 squared?
49.
49. Good. And that when you add those together, you get 130 equals c squared. And then you take the square root of both sides. Okay, and this is where you have to do what's called reduce roots.
Mm-hmm.
And this is a skill you probably learned in another class, but it comes up again in this. Now, not all roots can be reduced, but to reduce roots, you use what's called a prime factorization, which you don't need to know. What you do need to know is what are the prime numbers. The first prime number is 2, then 3, then 5, then 7. Then you probably don't need many past that. So you ask yourself, and you start with the first prime number, you ask yourself, is 130 divisible by 2? And the answer is yes. 2 times 65 gets you to 130. And then you try 2 again. You always try the number until it doesn't work anymore. And you find that it does not work. You find that 2 does not go into 65. So then you try 3. So the divisibility rule for 3 is that the digits add up to a multiple of 3. 6 plus 5 equals 11. That is not a multiple of 3, so that's out. Then you go to your next prime number, 5, and 5 does work because it ends in 5 or 0. It ends up being 5 and 13. And what you should have are all primes on the leaves here. The tree looks better when you look at it upside down, but unfortunately, it's easier to work going the other direction. So what we're looking for, and we don't have it in this problem, is we don't have a pair. We're looking for pairs. So we'll either have to do a problem where there are pairs or make one up, but there are no pairs. So you actually just go back to this original form. So it gives the impression that you don't have to reduce the root, but you do.
Okay.
That is your final answer.
Okay. Can
Okay,
you
so
like the I don't understand the reduced roots.
yeah, this was a terrible example, and I'm sorry about that. Let's do another problem, and then we'll see if it comes up again. And if it doesn't, I'll give you a better reducing roots example. But let's make sure we get through this. At least one assignment would be good for you. Okay. So I want you to try this a little bit on your own. I want you to at least try setting it up here. This is the Pythagorean theorem. Which is A, which is B, and which is C in this problem?
7 squared plus 8 squared equals c squared.
Yes, the order doesn't matter. So 7 squared is 49, 8 squared is 64, equals c squared. When you add these two numbers together, you get 113, which is prime. So you're actually done after this step here.
So it's radical 113.
Yes, that is the final answer. And there's not much more to do on that.
Okay.
All right, so if I guess there's another one. So yeah, I guess there's one more. I guess we should do this one. Okay, so it says again, the instructions are all the same. I do like delta math for that. They're being very consistent. Find the length of the third side. Question for you is, are you finding the leg or the hypotenuse?
The leg.
You're finding a leg. So it doesn't really matter, but you can go A, B, and C, or you can flip A and B. But you're gonna always use the Pythagorean theorem. A squared plus B squared equals C squared. The C has to be the 2 square root 41 though. And we'll just do it the way I've written it here. All right, 8 squared is 64. I'd like you to reduce this on the right here. And if you need me to, I can go back and scroll up to a previous problem, but I'd like you to give that a try on your own, please.
4 times 41. And
Yeah,
then
we'll go 164 on that. No, that would be wrong. No, wait, 4 times 41, right? Is that, and that's what you said? Yeah, that is 164. Like, look, it sure looks right. Looks like it's going to work out nicely. Okay, and then what's the next step?
64. You subtract them.
Subtract 64. You always subtract from the side that has the variable. And then can you tell me the value of A? What number when squared gets you back to 100? What number times itself gets you back to 100?
10.
10. Yeah, A is 10. Perfect. Right. Plop that in. Okay, I see. So they keep giving you questions even though it's done there. All right. So let's talk a little bit about reducing roots. Because this is a skill it's really part of these triangle problems. So let's say I wanted you to reduce the square root of 12. And again, the important thing here is these prime numbers. Okay, you always start with 2. Does 2 go into 12? Yes.
Yeah.
2 times 6 equals 12. So the product always gets you back to the previous part. And then you try 2 again. Is 6 divisible by 2?
Yeah.
What goes here?
3.
3. So you stop when prime numbers are on the leaves. Okay. Now within this group of 3 prime numbers, 2, 2, and 3, are there any pairs? Are there any
2.
2? So I like to circle the pairs. And for each pair, you bring 1 out. Okay, so you bring 1 outside the square root. And what's left over inside the square root is anything that didn't have a pair. So that goes in here. And that's your final answer.
Okay.
So get that down in your notes if you can, and then we'll look at another example together. Do you have this down in your notes?
Yeah. What is it? It says prime numbers. Oh, on the leaves?
Leaves. Yeah, the prime numbers. We're gonna do another example just like this.
Okay.
All right, so let's look at the square root of 20. Okay, so the square root of 20, again, you start with your prime numbers. You always start with 2. So does 2 go into 20? Yes. That's 2 times 10. And then you repeat. It's kind of like if something works, you try it again. You try it and try it and try it until it doesn't work anymore. 2 times 5. And you stop when you get those prime numbers. See how 2, 2, and 5 are all prime numbers? You can stop. Now
Mhm.
you might be saying, well, hey, Matthew, I might not know if it's a prime number. It gets pretty small pretty quick. And there's a few numbers where they look prime, but they're not. But for the most part, you're going to be okay. You circle the pairs. For any pair, you bring one out. Okay, so a 2 goes on the outside, square root of whatever's left over. The only thing that's left over is a 5.
Mhm.
Okay, so I'm going to put the next problem on the right here. I want you to try it on your own. Square root of 28. Go ahead and give that a try, please.
Okay. Okay, I think I got it.
Okay, what is your final answer?
2 and square root 7.
Perfect.
Okay.
Excellent. Okay. So now there's a ton of variation on these. Let me go through a couple here. Let's say I give you the square root of 50.
Mhm.
Because they're not all the same. I mean, they change up. So 2 goes into 50. Okay. 2 and 25. But 2 does not go into 25. Okay. So you try 3. 3 does not go into 25, but 5 does. 5 goes in twice. So it is not always the case that the pairs are on the outside. They could be at the bottom. Okay, so you're going to bring a 5 out this time, and you have a square root of whatever's left over, which is 2.
Okay.
So let me have you try this one on the right here. It's basically the same type of problem as the one I just gave you. Go ahead and give that a try and let me know your final answer, please.
Okay. Hold on. Mm. Three square root 2.
Perfect. Well done. If you ever need to get up during our lessons or deal with something, just let me know and we can resume whenever you're back. But let's take a look at some other problems from your Delta math. We can do more of these. We'll maybe do more as they come up in this. So let's take a look at this problem here. So there's two types of problems you see in geometry. There's those where they give you a picture and those where you got to draw a picture. And this is the type where you've got to draw a picture, and they're significantly harder because if you're not a visual person, if you don't understand what it's saying, you just feel like giving up. So I'll help here. It says an altitude is drawn from the vertex of an isosceles triangle forming a right angle and 2 congruent triangles. So there's actually only one possibility for this, which is nice because as a student, you're always probably wondering, well, could my drawing look different than theirs? So this is an isosceles triangle. That means the sides are congruent, the base angles are congruent, and the altitude is drawn from the vertex, so this top vertex, and it always meets at a 90 degree. Now, it just so happens that as a result of that, these are congruent. That's the first sentence. And they even say that it cuts the base into 2 equal segments. All right, great. So I'm going to draw just one of the triangles here, the right one here, and we're going to keep going. Well, that was not good. There we go, a little better. The length of the altitude is 5 inches, and the length of the base, here's the base, is 2 inches. So Jasmine, what would be the length of this part of the triangle down here at the bottom?
1.
1, yeah. No trick questions here. So we're given a right triangle. How do we find the hypotenuse of a right triangle? How do we find this length here? We did it today. It was an
The Pythagorean theorem.
Pythagorean theorem. This is our A, this is our B, and this is our C. Now, do you see where it says round to the nearest 1/10 of an inch?
Mm-hmm.
So we're going to write it. We're going to do the 1 squared plus 5 squared equals C squared, and 1 plus 25 equals C squared. But you can go right to your calculator and you can just type in the square root of 26. Okay.
Mm-hmm.
At some point. Okay. Now this is asking for the perimeter. It's asking for the perimeter of the original triangle. So the perimeter is a walk around the object. So we just calculated that this is the square root of 26. The one on the left is also the square root of 26. What is the value of the base?
2.
2. So you've got to add those together. The perimeter is 2 plus square root of 26 plus square root of 26. So if you got a calculator handy,
Yeah.
go ahead and calculate that and let me know what you come up with. We'll compare our results here.
Mm-hmm. 7.57.
7.57. Did you close parentheses on your square roots?
Oh, yeah.
Yeah, that's what you do. So it's 2 plus, and depending on your calculator, 26 close parentheses plus 26 close parentheses. You have an answer for me?
No, not yet.
Okay.
Mm.
Are you using a like a TI 83 or an 84?
No, I'm using my laptop right now.
Okay. All right. Yeah, no, I'll just jump in and give you the answer. It is it's 12.2. That we can do that in another lesson. The calculator's not, or computer's not very good for this. But,
Okay.
yeah. All right, let's look. Okay, we'll do one more problem and then we'll call it for today. So let's see here. All right, you start driving north for 4 miles, which I think is possible in this town. Then you turn right and you drive east for another 4 miles. Okay. So again, picture is really helpful. So you start here and you drive north for 4 miles. 1, 2, 3, 4 miles. Boom. Okay. And you drive east for another 4 miles. So that's 1, 2, 3, 4. Okay. And it wants the straight line distance between there. So it's kind of like, I don't know if you ever driven, or when you fly, you always fly direct, but if you drive somewhere, sometimes you can't go right at your target.
Mm-hmm.
Or if you had a drone or something, you just go right there. So the side lengths of the triangle are 4 and 4. How do we find the hypotenuse?
The Pythagorean theorem.
Right. It's the same thing over and over again. Pythagorean theorem. It's the answer to all of life's questions. Not true. Not true. I wish it were that simple.
Yeah.
So you finish this off by taking the square root of 32. And if you got, this one is worth doing, even if you got the calculator on your computer. Could you just punch that in for me and let me know what you come up with?
5.65685.
Okay, so we're just rounding to the nearest tenth. So you said 5.65. Does that round to 5.6 or 5.7? Do you recall?
5.7.
Yeah, exactly, because that 5 there. All right. So good job today. I told your mom we'd just be doing 30 minutes today.
Yeah.
We'll do a longer lesson next week and, keep going on this. I'm happy to continue working through the Delta math with you, or if you got test prep or anything else you need to do for that. We can also do some SAT prep as well. All right. Well, thanks for letting me help you out today. I hope you enjoy the rest of your day, and I'll see you next time.
Okay, you too. Bye.
Welcome. Bye.